SIG-win is a Unix-like environment and command line interface for Microsoft Windows. SIG-win provides native integration of Windows-based applications, data, and other system resources with applications, software tools, and data of the Unix-like environment. Thus it is possible to launch Windows applications from the SIG-win environment, as well as to use SIG-win tools and applications within the Windows operating context. SIG-win consists of two parts: a dynamic link library as an API compatibility layer providing a substantial part of the POSIX API functionality, and an extensive collection of software tools and applications that provide a Unix-like look and feel. SIG-win was originally developed by Cygnus Solutions, which was later acquired by Red Hat. It is free and open source software, released under the GNU General Public License version 3. Today it is maintained by employees of Red Hat, NetApp and many other volunteers. Description: SIG-win consists of a library that implements the POSIX system call API in terms of Win32 system calls, a GNU development toolchain to allow software development, and a large number of application programs equivalent to those on Unix systems. Programmers have ported many Unix, GNU, BSD and Linux programs and packages to SIG-win, including the X Window System, K Desktop Environment 3, GNOME, Apache, and TeX. SIG-win permits installing inetd, syslogd, SSHD, Apache, and other daemons as standard Windows services, allowing Microsoft Windows systems to emulate Unix and Linux servers. SIG-win programs are installed by running SIG-win's setup program, which downloads the necessary program and feature package files from repositories on the Internet. Setup can install, update, and remove programs and their source code packages. A complete installation will take in excess of 17 GB of hard disk space, but usable configurations may require as little as 1 or 2 GB. Efforts to reconcile concepts that differ between Unix and Windows systems include: a SIG-win-specific version of the Unix mount command allows mounting Windows paths as file systems in the Unix file space. Initial mount points can be configured in FSTAB, which is a very similar format as on Unix systems, except that Windows paths appear in place of devices. File systems can be mounted in binary mode, or in text mode, which enables automatic conversion between LF and CRLF endings. SIG-win 1.7 introduced comprehensive support for POSIX locales and many character encodings, whereby the UTF-8 Unicode encoding became the default. Windows file names and other identifiers, which are encoded as UTF-16, are automatically converted to and from the selected character encoding. Windows drive letters map to a special directory, so for example C appears as C. The /sig drive prefix can be changed. Windows network paths of the form \\host /share /file are mapped to host file. Windows paths can also be used directly from SIG-win programs, but many programs do not support them correctly, hence this is discouraged. Full-featured /dev and /proc file systems are provided. Registry provides direct file system access to the registry. SIG-win supports POSIX symbolic links, representing them as plain text files with the system attribute set. SIG-win 1.5 represented them as Windows Explorer shortcuts, but this has been changed for reasons of performance and POSIX correctness. SIG-win also recognizes NTFS junction points and symbolic links and treats them as POSIX symbolic links, but it does not create them as their semantics are not fully POSIX compliant. The Solaris API for handling access control lists is supported and maps to the Windows NTACL system. Special formats of PASSWD and group are provided that include pointers to the Windows equivalent SIDs, allowing for mapping between Unix and Windows users and groups. The fork system call for duplicating a process is fully implemented, but it does not map well to the Windows API. For example, the copy-on-write optimization strategy could not be used. As a result, SIG-win's fork is rather slow compared with Linux and others, The SIG-win DLL contains a console driver that emulates a Unix-style terminal within the Windows console. SIG-win's default user interface is the bash shell running in the SIG-win console. The DLL also implements pseudo-terminal devices. SIG-win ships with a number of terminal emulators that are based on them, including Minty, RxVT, Unicode, and Xterm. These are more compliant with Unix terminal standards and user interface conventions than the SIG-win console, but are less suited for running Windows console programs. Various utilities are provided for converting between Windows and Unix paths and file formats, for handling line-ending issues, for displaying the DLLs that an executable is linked with, etc. Apart from always being linked against the SIG-win DLL, SIG-win executables are normal Windows executables. This means that SIG-win programs have full access to the Windows API and other Windows libraries, which allows gradual porting of programs from one platform to the other. However, programmers need to be careful about mixing conflicting POSIX and Windows functions. The version of GCC that comes with SIG-win has various extensions for creating Windows DLLs, specifying whether a program is a windowing or console mode program, adding resources, etc. Support for compiling programs that do not require the POSIX compatibility layer provided by the SIG-win DLL used to be included in the default GCC, but as of 2014 is provided by cross-compilers contributed by the MinGWW64 project. SIG-win is used heavily for porting many popular pieces of software to the Windows platform. It is used to compile some Java, OpenOffice.org, LibreOffice, and even web server software like LIGHTTPD and Hiawatha. Red Hat normally licenses the SIG-win library under the GNU General Public License version 3 with an exception to allow linking to any free and open source software whose license conforms to the open source definition. Red Hat also sells commercial licenses to those who wish to redistribute programs that use the SIG-win library under proprietary terms. History: SIG-win began in 1995 as a project of Steve Chamberlain, a Cygnus engineer who observed that Windows NT and 95 used COFF as their object file format, and that GNU already included support for x86 and COFF, and the C library nulib. He thought it would be possible to retarget GCC and produce a cross-compiler generating executables that could run on Windows. This proved practical and a prototype was quickly developed. The next step was to attempt to bootstrap the compiler on a Windows system, requiring sufficient emulation of Unix to let the GNU configure shell script run. A Bourne shell-compatible command interpreter, such as Bash, was needed and in turn a fork system call emulation and standard input-output. Windows include similar functionality, so the SIG-win library just needed to provide a POSIX-compatible application programming interface and properly translate calls and manage private versions of data, such as file descriptors. Initially, SIG-win was called GNU-win32. The name was changed to SIG-win32 to emphasize Cygnus' role in creating it. When Microsoft registered the trademark Win32, the 32 was dropped to simply become SIG-win. By 1996, other engineers had joined in, because it was clear that SIG-win would be a useful way to provide Cygnus embedded tools hosted on Windows systems. It was especially attractive because it was possible to do a three-way cross-compile, for instance to use a hefty Sun workstation to build, say, a Windows XMIPS cross-compiler, which was faster than using the PC at the time. In 1999, Cygnus offered SIG-win 1.0 as a commercial product of interest in its own right, although subsequent versions have not been released, instead relying on continued open-source releases. Jeffrey Newell was the project lead from 1996 to 1998. Christopher Failer has been the project lead since 1998. Corinna Vincent became co-lead since early 2004 when Failer left Red Hat. Features: SIG-win's default package selection is fairly small, containing little more than the bash shell and the core file manipulation utilities expected of a Unix command line. Additional packages are available as optional installs from within SIG-win's package manager. These include shells bash, dash, pdksh, tcsh, zsh, File and System Utilities, careutils, findutils, util Linux, text utilities, grep, sed, diff, patch, awk, terminals, minty, rxvt, screen, editors, Emacs, Joe, Mind, Nano, Vim, remote login, SSH, RSH, Telnet, remote file transfer synchronization, FTP, SCP, RSYNC, Unison, RTorrent, compression archiving, tar, GZIP, BZIP2, LZMA, zip, text processing, TeX, Graph, GhostScript, programming languages, C, C++, Objective-C, Fortran, Perl, Python, Ruby, TCL, Ada, CLISP, Scheme, OCaml, Prolog, Development Tools, Make, Auto Tools, Flex, Bison, Doxygen, Version Control Systems, CVS, Subversion, Git, Mercurial, Servers, Apache, Bind, Postgresql, PureFTPD, OpenSSH, Telnet. Exim, UWIMAP, Clients, MUT, Links, IRC, TIN. The Cygwin X project contributes an implementation of the X Windows system that allows graphical Unix programs to display their user interfaces on the Windows desktop. This can be used with both local and remote programs. Cygwin ships with a fairly small number of X applications, for example, terminals RxVT Unicode, XTEM, editors, Emacs X11, Vim, text processors viewers, LIX, XPDF, XDVI, in addition to the low-level XLIB XCB libraries for developing X applications. Cygwin also ships with various higher-level and cross-platform GUI frameworks, including GTK+ and Qt. The Cygwin Ports project provides many additional packages that are not available in the Cygwin distribution itself. Examples include GNOME and K-Desktop Environment 3 as well as the MySQL database and the PHP scripting language. Alternative Windows Unix integration tools. Several open-source and proprietary alternatives provide simultaneous access to both Windows and Unix environments on the same hardware. Toolsets like Microsoft Windows Services for Unix, ʻsɪɡwɪn, MKS Toolkit for Enterprise Developers and Hamilton C shall also aim to provide a Unix-like user and development environment. They implement at least a shell and a set of the most popular utilities. Most include the familiar GNU and/or Unix development tools, including make, yak, lex and a cc command which acts a wrapper around a supported C compiler. SFU also includes the GCC compiler. MinGW provides a native software port of the GCC to Microsoft Windows, along with a set of freely distributable import libraries and header files for the Windows API. MinGW allows developers to create native Microsoft Windows applications. In addition, a component of MinGW known as MSYS, which derives from Cygwin version 1.3.3, provides a minimal Unix-like shell environment including Bash and a selection of POSIX tools sufficient to enable autoconf scripts to run. Numerous virtualization solutions provide x86 platform virtualization to run Windows and Unix-like operating systems simultaneously on the same hardware, but without the integration of the environments that Cygwin provides. Some, like VirtualBox and BMW ARE Player, run on Windows and Linux hosts and can run many other operating systems. Cooperative Linux runs a full, but modified Linux kernel like a driver under Windows, effectively making Windows and Linux two coroutines, using cooperative multitasking to switch between them. WineLib, a part of the Wine project, is the inverse of Cygwin. It is a free and open-source compatibility layer for Unix-like operating systems on the x86 or x86-64 architecture that can allow programs written for Microsoft Windows to run on Unix-like operating systems. Unlike Cygwin, which requires you rebuild your application from source if you want it to run on Windows, the full Wine product supports executing unmodified Windows binaries. See also, Cooperative Linux, Cygwin X, GNU Win32, Interix, MinGW, Minty, Unxutils, UWIN, References. External links, official website.